Okay, so let's look at P191 tutorial sheet 9 on capacitors. So I'm sure by now we know what capacitors are. They're just used to store energy in an electrical appliance, or not an electrical appliance, sorry, but a circuit. So we have question 1, which says in the circuit, capacitor 1 has a magnitude of 2 microfarads. Capacitor 2 is equal to capacitor 3, which has a magnitude of 0.5 microfarads. And the charge on the battery, E, is equal to 6 watts. Calculate 1, the combined capacitance; 2, charge on the combined capacitor; 3, charge on each capacitor. So these are questions that are direct or straightforward and direct to the point, because we can see to say in our combination of capacitors in the circuit, capacitor 2 is in parallel with capacitor 3, and the combination of these two is in series with capacitor 1. So in order for us to calculate the total or the combined capacitor of this circuit, we're going to say 1 over C total will be equal to 1 over capacitor 1 plus 1 over the combination of these two capacitors that are in parallel, because to say, in order for us to calculate the total capacitor of capacitors that are parallel to each other, we just say, for example, in this case, it's C2 plus C3. So if this is the combination, I'm just going to plug it into this formula to say over C2 plus C3, so that it gives us the combined capacitance. So 1 over C total will be equal to 1 over C1, which has a magnitude of 2 farads or 2 microfarads, plus 1 over 0.5 plus 0.5. This is basically going to give us 1 over 1, like this. So if I plug this into my calculator, I'll just plug it direct into my calculator on the right hand side. Okay, so I'm getting a final answer. My combined capacitance is equal to 0.667 microfarads. 0.667 microfarads. That's the combined capacitance of this particular circuit. 0.660 microfarads is the combined capacitance. So that is all on question 1. We can go to the next question, which is saying calculate the charge on the combined capacitor. Calculate the charge on the combined capacitor. So we are going to use the formula that gives us the relationship between charge, capacitance, and the voltage around the circuit. So this is the formula we're going to use. Charge is equal to capacitance multiplied by voltage. So we are looking for the charge on the combined capacitor, or and we have the combined capacitor already, which we are from calculating, and we have the voltage of the battery that we are also from calculating. So the capacitance that we're going to use should be in farads. Here, the answer that we've gotten is in microfarads, which means the one that we're supposed to use in this particular formula should be in microfarads, or should be in farads, not in microfarads. Supposed to use the SI unit. So this is going to be equal to the capacitance, which is 6, or I can say 6 point or 0.667 times 10 to the power minus 6, multiplied by the charge, which is 4, which is 6, sorry. This is 6. Plug this into my calculator, I'm getting my charge, which is equal to my charge, which is equal to 4 times 10 to the power minus 6. Getting my charge, which is equal to 4 times 10 to the power minus 6. And that is it in coulombs. So the combined charge, or the charge on the combined capacitor, is equal to 4 times 10 to the power minus 6 coulombs, or which this is the same as 4 microcoulombs. 4 microcoulombs. So the charge on the combined capacitor is basically 4 microcoulombs. We can go to the last part of the question, which is saying we should calculate the charge on each capacitor. Calculate the charge in each capacitor. So in order for us to calculate the charge in each capacitor, we are supposed to take note of some things. We've already talked about the connection between the capacitor, or the 3 capacitors that we have here. We can see to say capacitor 1 is connected in series with the parallel combination of capacitor 2 and capacitor 3. And we know to say when we are looking at a circuit in series, the charge is the same on each branch. but the voltage is going to divide. So what are we going to, or what are we going to notice in this particular case? We're going to notice that since C1 is in series with this parallel combination of these two guys, the charge on C1 is going to be equal to the total charge that is stored in this whole circuit. So I can give an example since we've already solved this. Let me just grab it. We're basically going to say C1 or Q1, the charge which is in capacitor 1. Okay. So I've said that since C1 is in a series with a parallel combination of C2 and C3, the charge that is going to be on C1 is equal to the total charge that is stored in this particular circuit, which means Q1 is actually equal to what? Is actually equal to Q total. Like that. And what does that mean? That means Q1 is equal to the charge that we are just from calculating, which is 4 microcoulombs. That is Q1, or the total charge that is stored in the circuit. Okay, so from there now, we can find the voltage across C2 and C3, which is or which are in a parallel combination. So we have the voltage E from the circuit, which is 6 here, and this voltage is split between C1 and this parallel combination that we have here. So we have this total voltage of 6 volts, and this guy is split between C1 and the parallel combination of C2 and C3 because they are connected in series. So we're going to say the total voltage is equal to the combination, or V1, sorry, plus V2, V3, like that, where V2, V3 is the voltage that is on the parallel combination of C2 and C3. So we can now calculate the voltage that is across C1 using this formula. V1 is equal to Q1 over C1, like that. This will be equal to 4 microcoulombs over the value of C1. I said it's 2 microfarads, 2 microfarads. And this is going to give us V1, which is equal to 2 volts. V1 that is equal to 2 volts. From there, we can find the voltage now that is across the parallel combination of V2, V3. Can now calculate the voltage that is across the parallel combination V2, V3. And as usual, we're going to say V2, V3. So I'll use V2, 3 is equal to total voltage minus V1. So this will be equal to 6 volts minus 2 volts. So that means V23 is equal to 4 volts. V23 is equal to 4 volts, just like that. So again, from this one now, the V23, can now calculate the charge that is on C2 and also the charge that is on C3. So we're going to say Q2, don't have enough space now. Let's go to the blackboard. We're going to say C2 or Q2, sorry. Q2 will be equal to V23, or this is going to be equal to C2 multiplied by V23. So this will be equal to 0.5 microfarads multiplied by 4 volts. Hence, the charge on capacitor number 2 is going to be equal to 2 microfarads. We can now go to the last one, capacitor 3, which we're basically going to do the same because the magnitude of capacitance in C2 and C3 is the same. We're still going to say Q3 is equal to C3 multiplied by the voltage across it, capacitor 2 and 3. And this is going to be equal to 0.5 microfarads multiplied by the voltage, which is equal to 4 volts. And this, ladies and gentlemen, is going to give us a Q3, which will be equal to 2.0 microcoulombs. And just like that, we are done. We've calculated the charge on the individual capacitors. So 2 microcoulombs and 2 microcoulombs on C2 and C3 respectively, whilst we have 4 microcoulombs on C1. And that, ladies and gentlemen, we are done with question 1. That means we are done with question 1. Can now go to question 2, and question 2 is saying determine the equivalent capacitance between A and B. Determine the equivalent capacitance between A and B. So this is a very, very simple question. And the first step we're going to do is calculate the capacitance or the equivalent capacitance of the capacitors that are in series. So you can see to say we have this capacitor, the 24 microfarads capacitor, the 12 microfarad capacitor, and the 8 microfarad capacitor, which are in series. So we are going to work with these first, then we're going to add that capacitor, or we're going to find the summation of these, or the combination of these together with this one, because they are in parallel with the 4 microfarad capacitor. And the combination of these four is going to be in series with the 5 and the 6 microfarad capacitors. So I'll start by doing that. I'm going to say 24, 12, and 8 that are in series. I'll start with that. That is question 2. That is question 2. So I'll say my 1 over total capacitance will be equal to 1 over 24 microfarads plus 1 over 12 microfarads plus 1 over 80 microfarads. Is it over 12? Let me just counter check. Yes, okay, it is over 12. So I'm going to get 1 over CT being equal to, I can add these three. Can add these three. I'm having let's say 1 over 24. 1 over 24 plus 1 over 12 plus 1 over 8. Okay, so this is giving me 1 over 4. So I have 1 over C total being equal to a simplified fraction, which is 1 over 4. Like that. So I'll cross multiply, and I'm going to get 4 being equal to total capacitance on the capacitors that are in series. So 1 over 4 will be equal to 1 over CT, which means 4 is the total capacitance on these three capacitors that are in series. So these three capacitors, their equivalent capacitance is equal to 4 microfarads. Did I put the units? This will be equal to 4 microfarads, like that. Okay, so the combination of that is in parallel with the 4.0 microfarad capacitor. So what we're going to do, we're going to add that. So say C total, I'll keep going down. C total will be equal to 4.0 plus 4.0. So C total will be equal to 8.0 microfarads, like that. So the combination of the capacitors that are in series together with the capacitor that is in parallel with those three is giving us a total of 8 microfarads. Now we can find the combination of these four. We found the combination of these four as 8. The combination of these four is 8, and this combination is in series with the 5 microfarad capacitor and the 6 microfarad capacitor. So we're going to find the total of those three combinations now. So which means 1 over the final total capacitance will be equal to 1 over 5 plus 1 over 6 plus 1 over 8. Now I'm going to plug these into my calculator just the way they are to get 1 over CT being equal to. Let me just plug them into my calculator. I have 1 over 5 plus 1 over 6 plus 1 over 8. And that is giving me a fraction of 59 over 120. That's the simplest fraction. I'm using my calculator, so it shouldn't surprise you a lot. It will be equal to 59 over 120. And what does that mean? I'm going to go to my blackboard. I'm having 1 over CT being equal to 59 over 120. If I cross multiply, I'm going to get 59 total capacitance being equal to 120. I divide both sides by 59, even this side by 59. It means my total capacitance in this particular circuit will be equal to 59 divided by 20. 59 divided by 20, or 120 divided by 59, 2.03. 2.03 microfarads. That is the equivalent capacitance or the total capacitance in this particular circuit that we've been given right here. The equivalent capacitance between points A and B is equal to 2.03 microfarads. Okay, that is that, ladies and gentlemen, on this one.